Okay, here's your piece of material that's 12 inches by 11 inches. And we're cutting these little squares out of each corner, and we don't know what size that X should be, so we're using the letter X for each corner. And then you can see from your diagram probably that you can fold up these sides along these dotted lines and create a box with an open top that has a height of X. And so the volume of that box will be length times width times height. And if we've chopped off an X at each end for 12 inches, then 12 minus 2X will be this dimension. And 11 minus 2X will be this dimension, and the height will be X. Now, if you want to find the derivative, you could multiply this all together, which gives you this. Find the derivative, which gives you this. Set the derivative equal to 0 and solve for X. You might notice that every term is divisible by 4 to simplify your work. Turns out this does not factor. So here's 3x squared minus 23x plus 33. I'll provide a link to a Desmos graph that show you that's an upward opening parabola. And where that equals 0, which this is again the first derivative, is at b squared plus the square root of that mess all over 6 and 23 minus the square root. Now we have to reject this answer because if we cut that amount from each end, we'll be over 11 inches. So this is too big, but this one's not. So we're going to cut a square from each corner that's about 1.9 inches. Here is an exact answer. And you technically should take the step to prove that this number is generating a maximum volume. You could do that by finding the second derivative and then plugging this number to see if it gave you a negative result or a positive result. It should give you a negative result. Or you could apply the first derivative test. But I'll leave that to the watcher of the video. There you go. Hope that helped. If you have any questions, post a comment.